So this presentation is in two parts. The first part is my part, building the controller, and my brother will be about programming the board and developing software. The board. I tried to include as many features as possible on the board. It was a challenge considering all the constraints. I found it pretty well. Included an ultrasonic sensor connector, line following sensor connector, dual motor controller, servo motor connector, controllable LED just because I could. This board was designed in Eagle and is designed to fit onto a Raspberry Zero. Main reason for this was that I could fit lots more boards on a 10cm by 10cm piece. I had to put on as much as possible. There's some features I didn't manage to include, like a safety diode and a voltage regulator, because I was hoping I could use the power supply in to power the Pi, but never got that far. It is not a Pi hat, because I'd need an EEPROM. I need it to fit exactly into these specific dimensions. I need to have the safety diode for back if I want to pack power, and I just can't be bothered. And EEPROMs are they range in price, so it will require more parts, more prices, and it wouldn't quite fit into my price budget, which is £1. I nearly made it, but you can see how much I overshot near the end of this presentation. Now, the schematic. The parts were quite hard to find. I used L293D here, because I had the built-in diode. Otherwise, I'd need extra parts. However, it is current limited, so you can only have a ½ amp motor. Also, this is an old diagram, because this 40-pin connector, I thought it was perfect until I put it into board mode, and the 40-pin connector was for some strange reason about 2mm too narrow. I didn't know that there was another standard, so I had to redo the thing, and it made a lot of mess. I think that might be where I made a mistake. The board turned out to be extremely crowded. It couldn't auto-route everything, but I also had to change track sizes because I needed some of them would take more current, so the ones to the motors or the ones with the main power supply in. Some of them wouldn't. I didn't manage to fit in all my features on here, as in where would you put them? Pretty much everywhere you look, you see there's a track. This is the input for power for the motors. This is motor controller, general purpose input output connector. I thought this would be brilliant because you may want more connections. So these are just raw, just straight off the bottom. The boards are 10cm by 10cm because the PCB supplier I was using actually charged you if they had to trim the board. So the cheapest one was 10cm by 10cm. And that is the maximum size of the free version of Eagle. So I Panelised it, but the PCB company would actually charge me. So I could fit 4 boards on the PCB, so I could get 20 boards, the same price as getting 5. Pretty good, considering I didn't actually have that many ideas for what I could do with 20 boards. I thought, good deal, why not do more, because I could. They would charge instead of £15, £20. So I went, no way, that would basically be my budget blown. So I did it all myself, and I had to build a little wooden frame for me to cut out with, which to some extent worked. I would also mention, I ordered it on the first attempt. It failed when they just visually check, and it said, "Hi sir, please kindly added connection bits and milling path the," until eventually I managed to decrypt that. Basically means I had to find the milling part, so I undefined it and it just used the same size piece for all of them, so I had to drill out a little bit bigger. It only cost £2.37 for 20. Sounds good, right? But then you got the postage, so it equaled £15. So currently each board is at 75, and that's not including parts. I made a wooden holder to cut out each of the boards, so I could get a nice straight cut, straight down. I got very worried on some occasions that I cut a track, but I hadn't. If you're planning on doing this at home, feel free, just don't do it on top of a washing machine. Only tip I've got, Do not cut stuff out of the washing machine. I got the working area ready. Soldering iron. It became pretty messy pretty quickly because of the sheer number of components. Spare fuses for my meter if you're wondering what they are. L293Ds are just about visible. See some PCBs at the bottom, PCB underneath the meter. All the resistors. The resistors are extremely cheap. See if I can find my... Oh, you can't see my favourite components. Ah, there they are. This bag is full of the green screw connectors. They're a brilliant value. Yeah, I did run out of solder as well. I had a whole solder dispenser. Ran out. So I had to buy a giant wheel of solder. So it took me a long time later and I had 20 boards ready. I did find 2 faults, so they didn't work first time. There was one wrong GPIO pin. I'd connected it to ground 1 pin over from the pin it should have been. And I'd connected my ultrasonic sensor to the 3.3 volts and not the 5 volt power, which now means that there's no 3.3 volts on the board. Thankfully, I found a way I could just about put a little jumper across in certain areas. Now, the cost. The PCB was 71 pence, including postage each. L293D was 18 pence each. Capacitors were 1.3 pence each. The other capacitors were 3 pence each. The resistors were just under a penny, extremely cheap. 4-pin connectors are 4 pence each. 2-pin connectors were 5 pence each. 40-pin connector for the Raspberry Pi was 27 pence. And others were 11 pence. A total was £1.67. Now, what do 20 boards look like? Like that. It's a lot. Unfortunately, I noticed as I was just photographing this that there is a board which is I didn't finish. One board and spot it, so the answer soon. Oh yeah, my brother was using this to test out his code. This one's the odd one out. I was testing on this board, hence it's slightly out of place. After testing every single board, I was completely tired. I'm gonna be honest here, I soldered maybe half of them. After soldering 10 boards, you kind of fall asleep and go, oh. So I made my dad do the rest. Thank you for listening. I'm going to pass over to my brother's presentation.
Hello, my name is Victor Sattel. I will be doing my presentation on the code which I made for the motor board. Well, here it is. It can be connected onto a Raspberry Pi Zero as shown. It has 3 ultrasonic sensor slots and 2 line follower also for motor sensor slots. These are all the imports I've done for my code. Right, so ultrasonic sensor, setup sensor 1, if you got it. So the reason why you have to set them up is because if they try setting up and they're not there, it gives errors into the code. That's why I've split them all up and not just done it all at the start. And then sensor 1 dist will print and return ultrasonic sensor 1's distance. Pretty simple at this point. Well, LED on will turn the LED on, and LED off will turn the LED off. As you can see here, LED on will set GPIO pin 20 high, and so the LED is plugged into GPIO 20. LED off will turn it off. Run move the robot, motor 1, motor 2, and duration. You move the motor for that amount of time, and it will also print that it is done so. R equals robot, and you can see these are the 2 values for the motors here, 11, 9, and 8 and 7. Then with robot, motor 1, motor 2, time, and so if you just put in how much you want to move it, 1 to -1 here, 1 to -1 here, and how long you want to move them. It will move for that amount of time, and then it will stop. Okay, so line sensors. One setup line sensor 1 to set up line sensor 1. Sensor 1's on pin 25, and sensor 2 is on pin 19. Over here you can see that when line is seen, basically it will just check line, and then when it has seen line, it will print line seen and return true. And over here you can see it plugged into the board. You can run clearboard to clean up the GPI opens. And here are the pinouts. These ones here are the line follower connections. And these ones are for anything else you may wish to plug stuff into. Alright, that's it from me. Hope you've enjoyed the presentation.
Okay, any questions?